Thank you everyone for joining today. My name is Nathan. I am a marketing manager at Data Science Dojo. And today I'm joined by Scott Fincher and Elizabeth Richter. You both work at KNIME, Scott, Data Science Community Manager, and Elizabeth, Data Science Publisher. And you're going to be taking us through an overview of text mining and NLP techniques. And then we're going to do, I think you said a couple of demos using the KNIME Analytics platform. So Scott, I think you mentioned you were going first.
My name's Scott Fincher. This is data scientist. It's what I used to do. Now I'm the data science community manager, but Lisa and I work on the same team at KNIME, the evangelism team, and a lot of our job is just explaining to people how our software works, getting them familiar with it. What are we going to do today? We'll be talking with you about, first, text processing philosophy and specifics, and how we approach that in KNIME. And then we have several different demos for you. The first one I'll be doing is a sentiment analysis example, how we can build a quick model to categorize movie reviews in this case. Lisa's going to show you a topic analysis example based on the LEA algorithm. And then if we have time, I have a little bit of a live Twitter demo that I'm going to show you where we can apply sentiment analysis to tweets that we'll pull in and we'll see them on a dashboard together. And then just some resources, follow-up material for you there at the end. But we've got a lot of ground to cover and not necessarily that much time to cover it. So I want to go ahead and get us started. And we're going to jump right into, before the philosophy, one slide about KNIME. So for those of you who aren't familiar with KNIME, what we offer is an open source GUI-based analytics platform to build your workflow. So you're not going to be writing a lot of code, to do your text processing unless you want to. You could do that within KNIME, but we have this visual tool, and just for the sake of orienting you with the nomenclature, I want to explain what it means when I say node, workflow, or component. So a node in KNIME is this little yellow box that you see at the top of your screen. Not all of them are yellow, but this is a group by node. So some data comes in the left-hand side, other data goes out the right-hand side, and in between, we do some aggregation on the data. There's all sorts of different nodes. There's literally hundreds, thousands of nodes that we have, whether that's reading in data, doing transformations, training a model, building visualizations. We have nodes for all that stuff. So a node does one task on your data. And we combine the nodes together to build what we call a workflow. And that's what you see on the second line here. The workflow in this case is reading in some CSV data, does some simple filtering, and then on the right-hand side creates a couple of visualizations. Of course, workflows get much more sophisticated and interesting than this, but you get the idea. And then at the bottom is what we call a component. This is a little gray box. What's inside the gray box is a bunch of nodes. And so the idea is if you have a series of nodes that do a frequent task that you need to reuse or share with someone else, you can build a component that contains those nodes and use it over and over again. It's kind of like building, a library or making a function call if you're coming from writing code. That's kind of what a component is like. So that's nomenclature for you. You're going to see nodes and workflows when we get to the demo. I think it'll be a little bit more clear then. But before we do that, let's talk a little bit about the philosophy of text mining and text processing, since that's what our whole talk is about today. So if you've never done this type of analysis before, text processing mining is its own discipline, right? We've got somebody on the call here who has their master's degree in text mining. So in the wider field of data analysis, it's its own discipline and has some specific things to think about. When we attack text processing within KNIME, we look at it at these different 5 stages. So the first stage that you see, the left bubble, is ingesting the data in some way, bringing the data into KNIME, whether that's from Excel, tweets, a flat file. If you're unlucky, maybe you have to read PDFs. You got to get that data into KNIME to do something with it. So that's step 1, reading in the data. Step 2 is enriching the data, and that means tagging it in a way that adds additional information. So we might, if you're looking at the second bubble here on the bottom, we might take a look and say, okay, I'm going to identify person, places, or things. Like, your name is Rumpelstiltskin from the fairy tale, right? We could identify Rumpelstiltskin as a person. We could also enrich by tagging parts of speech, which we're going to do as part of our demo. We could tag sentiment. There's all sorts of things we could do to tag. And so that's the second step. The third step is pre-processing the data, which involves lots of little steps. The idea behind pre-processing is filtering things down, reducing the feature space, getting rid of words that aren't going to help us in our analysis. And there's lots of different ways we can do that. I'll show you some specific nodes. You can see in this example here, we're graying out words like perhaps, your, and is, because they're not really that useful for the purposes of sentiment, certainly, but just generally you want to get rid of words if you can. Then after we have done pre-processing on our data, we go to the fourth step, which is transformation. That's taking human readable text and transforming it into some mathematical representation that our models can then understand. So we have a specific node or set of nodes we're going to use for this in KNIME to do the transformation into a sparse vector matrix, essentially a series of ones and zeros, or if you're a little more sophisticated, some weights might be thrown in there. When we have that matrix, we can then turn around and feed it to our algorithms, whether we're going to be doing clustering like with LDA, we're going to be doing classification for sentiment, whether we just want to build word clouds and do some specific text visualizations. That's all things that we can do after we have that mathematical representation. So that's the last step. So this is just the general overview of these 5 steps, and you're going to see these come up as I go through the remainder of the slides and also when we do the demo as well. Couple of things before we get into the specifics of the nodes. So you're already familiar with things like types of variables, integers, strings, longs, doubles, right? This is how we store data in software programs. Today, we're going to use a couple of different additional types that may be specific to KNIME that are for text processing. One is called a document. So a document is going to consist of the string that we're interested in doing something to, along with a bunch of other meta information associated with it. So we can store not only the text, but who wrote it, its categorization, is this positive or negative in terms of sentiment, whatever it is, when it was written, just other types of metadata. We store that in the document together with the text. We can then turn around and extract that data later when it's useful to us. So whenever you see a document in KNIME, just know it's not only the text you're looking at, it's also this other additional information. We also have a data type called a term that we use in KNIME. A term is a combination of a particular word along with a tag that is some description of that word. So tags could be sentiment, they could be parts of speech like we see in this example, they could be identifiers of other types, but a term consists of those two things, the word itself and the tag. So if you look on this right-hand side in this table, going down, we're reading some restaurant review. Very good Thai food, been there on Monday. Each of the words there it has a tag associated with it. In this case, it's parts of speech, and very is an adverb. Good is an adjective. Thai is a named pronoun, and so on, right? So we store this information in a term field within KNIME. So just be aware of that when we talk about some of these nodes here in a little bit. Okay. The very last thing I'm going to end up showing you today is this dashboard, if we have time, I think we will, that we're going to use to classify tweets live and then build a word cloud using the words that are in those tweets and show the tweets themselves. This workflow just takes a really short time to run, and I want to give you an example of how we could take the model that we build and actually apply it in a context that other people who maybe aren't software developers or using KNIME could also use. So this is one of the things we'll show you here at the end. But before we get to that, let's go ahead and talk more specific about our sentiment analysis example. What are we going to do? There's a lot of different ways we could approach sentiment analysis. You see 3 of them here. There's a lexicon-based approach where we could tag words that have a positive or negative connotation and then basically count up those words and calculate an index, right? And that for our entire string, that would give us some index of how positive or how negative it is. Not that sophisticated approach, but it can be useful when you don't have supervised data to start working with. The one we're going to use today is the machine learning approach, where we actually have movie reviews that are already classified for us. We're going to do the pre-processing, use a simple decision tree to suss out how they should be classified. And we also have a deep learning approach. You could do this in KNIME, where we actually build a neural network consisting of multiple layers. One might be, an LSTM, like you see here, a dense layer, and then use Keras on the back end of KNIME to do the prediction. This is overkill for what we're doing. We're only going to have 2,000 movie reviews to work with. You need a lot of data for deep learning, right? But just so you know, KNIME can take these other approaches other than what we have the time to discuss today. And if you want to get into more of the deep learning stuff and you'd like to get started, we have example workflows that we can point you to later. But we'll be doing the machine learning approach here in the middle. And in particular, I don't have a slide for this. I guess I took it out. We have 2,000 movie reviews. 1,000 of them are positive. 1,000 of them are negative. That's going to be or a subset of that will be our training set. And that's what we're going to build a model on. So coming back to this idea of our 5 steps in our philosophy, the first one that we're going to do is reading and parsing the data. So we have a bunch of these different orange nodes in KNIME that you see here to read in data, depending on the source that it comes from. We're going to use a file reader in our example. The most important node that we're going to use is something called the strings to document node, where we take our input string and we convert it to a KNIME document, like I told you about before. The reason that's important is because all of the downstream nodes require a document field to work on, whether it's the enrichment, the pre-processing, whatever it is. So this is the first step usually in our analysis. After we read in the raw data, we convert it to a document. The second step here is enrichment. I want you to focus on the right-hand portion of this slide because that's what we're going to do in our demo. We're actually going to tag the different words in our text with parts of speech. Why do we want to do that? Because later, during pre-processing, we're actually going to filter out words that are of less interest to us and keep things like nouns, adjectives, verbs, and adverbs that have a little bit more meaning for sentiment. So after we do this tagging, it allows us later to reduce the feature space. As I mentioned before, you could use a dictionary tagger in this lexicon-based approach to tag positive and negative words. There's other different taggers that we have within KNIME that are even used kind of outside the text mining we would do for things like biochemistry, named entity learners, things like that. You can find the different tagger nodes for those different applications in the KNIME node repository, which we'll show you in a minute. Step 3, this is pre-processing. So pretty much every node that you see here is pretty simple in its approach. They all do specific things that are required to boil down our text into a smaller feature space. So we want to get rid of things like punctuation. We want to get rid of words that are maybe 3 characters or less, because typically those words don't have very much meaning. We can get rid of stop words. That's a term of art in text processing, getting rid of words that we know don't have meaning or may appear a whole lot and would otherwise clutter things up. If I was, doing an analysis of the KNIME forum, for example, I might use KNIME as a stop word because it's going to appear all over the place, right? I can provide a list of words to get rid of. We also have a built-in list of stop words, things like a, and, the, but, who, where. They're not very useful. We can get rid of them. We can also do things like stemming. I probably don't really have time to talk about stemming. Maybe we can talk about it later when we get into the demo. And then ultimately additional filtering so that we can keep only the important words based on the parts of speech. Also, we do case conversion too, right? Because we don't want our model to distinguish between, in English, we capitalize the first letter or the first word in a sentence, but that doesn't change its meaning, right? We don't want capitalization to clutter things up, so we can get rid of that too. All of these pre-processing steps are pretty common across the different types of text analyses you will do. You might even build a component out of a series of nodes like this. If you find yourself using the same methodology over and over, it can help you in your other workflows. So step 4, we've got a couple more of these before we get to the demo. Transformation, right? This is where we take the human readable text, convert it into some mathematical representation of the data. That's going to be done using the document vector node. We also have a bag of words and a term frequency node here to be able to break the words in a sentence up. It removes the context, and then we can calculate frequencies to do interesting things like build word clouds later and other types of visualizations. We can see how words appear not only in our individual reviews, but how they appear across all reviews, and that can give us some useful indicators of the importance of particular words. But the document vector, what it's going to do is essentially take our words and transform them such that we have all of our rows will be, in our case, movie reviews. So we'll have 2,000 rows, and then we end up with a column for each pre-processed term. We end up with about 20,000 columns, one for each of the words, essentially, that you see across all the documents. And then that big matrix, 2,000 by 20,000, is going to be filled with a bunch of ones and zeros, mostly zeros, where the ones will indicate where a word appears in a particular document. I'll show you that here in a minute. But that matrix is what then we can use to build a model. This part, the focus on the right-hand side of the slide, the machine learning, this is where we actually build the model. So you're probably already familiar if you've done any, building of models before. We're going to partition the data into a training and test set. So we'll take our 2,000 movie reviews and split them maybe 70-30, 80-20. Take the larger data set and train a model. In this case, a pretty simple decision tree. Apply that model using the decision tree predictor. And then once we've applied the model, we can evaluate it using the score to see how well it performed. Did we create a model that actually has any predictive ability? That's an important thing to know before we go deploying models out in the world, right? So that's what we're going to do in the last step. Okay, I've talked a lot. I know I've gone super fast through this material. This is stuff that if we were teaching a class, we may take more like 45 minutes or an hour to go through those nodes. And I know none of you have seen KNIME before. So let me take a minute to actually show you KNIME. So somebody please tell me if you're not seeing KNIME on my screen right now, Lisa or Nathan, because I just switched over. I'm going to assume you can see it. So all good? Okay. So what you see here is the KNIME Analytics Platform. And in particular here is the solution. I'm not going to give you a tour around the whole interface in detail, but basically this part up here in the top left is where our workflows are stored. The bottom part down here in the bottom left is where all the different nodes live, so we can drag and drop these into our workflow. The right-hand side is a description of the different nodes and what they do. It's essentially the documentation. And then I have some console messages down here for when I execute things that tell me if I have any errors or warnings I need to follow up on. I'm going to make all this go away for a second because what I want to do is focus solely on the nodes and showing you how this bit works. And let me do a quick time check. Okay. So what are we looking at here? First thing we're going to do is read in the data. So we have our parts 1, 2, 3, 4, 5. These are the 5 different, things I showed you in the philosophy slide. We read in our data. This is our IMDb reviews. I've already executed all of this, by the way. This workflow takes about a minute or 60 to 90 seconds to run. I've already pre-executed it, so I can just show you the data at each step. And it's worth pointing out too, Lisa will tell you at the end where you can get this workflow for yourself if you want to try it out locally on your own machine. We just didn't have the time to walk through everybody live on the call, so I'm just going to show you some stuff. So this file reader reads in the data. I can go ahead and take a look after I've read it in and see what the data consists of. I have an index string. I have a URL that has the location of where this particular review came from. Then I have the text itself. This is the part we care about, right? Lots of text. I scroll all the way over, and on the right-hand side, I have a string that is the classifier. Is this positive or negative? 1,000 of each of those. So that's our raw data. That's what we're starting with. The next thing we have to do is convert that to a document. So to do that, I use the strings to document node. Whenever I double click on a node, it brings up the configuration. And this is where I would make all the changes to the node, right? So I don't have to write code using KNIME. I can just use the dialogues to make my choices, and it's going to save everything. So in this case, I just tell the node my text is in the text column, and then I provide some additional meta information. The sources come from the URL. The category comes from the sentiment column. That's really important because this is going to be our source of truth for whether something is positive or negative. And then some other options that we don't have time to talk about. There's the tokenizer down here that actually I tell it that it's English. KNIME can do or can process text from other languages other than English if you have those other language packs installed. So after I convert to a document in KNIME, what we end up seeing is all of this, basically our same data set. And then I get this new column called document, and it doesn't appear to have anything in it because what it's doing is showing the title. In this case, we don't have a title for our movie reviews. We just have the reviews themselves. And so in this table, it just shows these blank quote marks. That doesn't mean there's not anything there. There is, in fact, the text along with the other metadata is stored here. And we could use a different node to see exactly what's going on inside the document that I'll show you in a second. Just if you run this later by yourself, don't be confused and think, there's nothing in my document column. No, there's something there. It's just the way it's displayed in the table. Okay, what do we do as far as enrichment goes? Here we use the POS tagger, the part of speech tagger, where we say, look at our doc and go ahead and do the tagging. There's not really much that we have to do here. After we do this result, again, we have just the document column and we think, hey, I can't check anything. What's in here? This is where the separate node that I mentioned comes into play, the tagged document viewer. So in the tagged document viewer, this is where we can actually look at the results of our tagging. This takes a second to open up because it's essentially opening a Chromium browser window. And here's one of my reviews. Maybe I show the first 5. You can see all of these different reviews have now tagged, follows is a verb, dwelling is a noun, high is an adjective, and so forth, right? So all of our words have been tagged. So we're getting started with our analysis now. The next thing that we want to do are these pre-processing steps. Get rid of punctuation, get rid of the stop words, do the stemming, reduce words that appear in different forms. Like the example I often use is dance, right? The word dance has a verb form, a noun form. It has past tense verb forms. There's a gerund form, dancing. All of those words essentially can convey the same concept. So we can use the stemmer node to boil those down into a single stemmed version of the word. In this case, it might be D-A-N-C to represent all of those dancing words. There's a trade-off, right? It becomes less human readable when we do that, but it boils down our feature space to make things more palatable when it's time to train the model. So this is still something we're interested in doing. We do all of this pre-processing here in the middle, and I'll just copy this node here, the tagged document viewer, and actually put it over here now, because I want to see what are the changes that have been made now that I've done all this pre-processing. It's going to look quite a bit different. A lot of the words are gone. Everything is still tagged, but a lot of the words are gone. And we've only kept, in this case, nouns, verbs, and adjectives. So we got rid of the conjunctions and prepositions and all of that other stuff to try to just have these single words that we think are going to be more interesting. And you can see that they're stemmed, right? Like here's the word purpose, P-U-R-P-O-S, the word honesty, H-O-N-E-S-T-I, a stemmed version of those words, again, to reduce our feature space. So after we've verified, we've done all that cleanup, we can do the transformation. I'm not going to spend any time on these first two, the bag of words and the term frequency. What I would rather show you instead is the document vector, so you can see the mathematical representation of converting these human readable words into what is essentially a matrix. So I mentioned before, and let me blow this up a little bit, make it bigger. We have 2,000 rows here, one corresponding to each movie review, and almost 20,000 columns, each one corresponding to a stemmed word, again, M-O-V-I, that's movie, right? Corresponds to a stemmed word, and those are all of the words that appear in our corpus. The corpus is the entire collection of our movie reviews. The 1 or 0 is just an indicator of whether this given word appears in a given movie review. So this is mostly zeros, but now we're in matrix form. This is something that models can understand. What we can then do is take that document vector and feed it over here into the classification bit. We pull our category back out of the original document because we want to be able to use that for classification. We do the partitioning here. We split 70-30 in this case, and we use stratified sampling on the document class. So we make sure we have the same proportion of positive and negative reviews in our training set as we do in the test set so that we don't end up accidentally biasing anything. And then we train the model. The decision tree learner, you could use something more sophisticated like XGBoost or a random forest with custom parameters. We have nodes for that too, but the decision tree is easy and it works fairly well. We just tell it, here's the class column that we want to classify, the document class. There's other options here that you can use to tweak it a little bit that I won't go into. And you can even see the results of the decision tree if you wanted to. In this case, it's maybe a little hard to interpret because we have so many different words in the decision tree, but you could actually boil this down to run down all the different words to see whether something is positive or classified as positive or negative. After we've trained the model, we apply the model using the decision tree predictor. And what the predictor is going to do is give us, again, our same large matrix here in this table, along with some other additional columns at the very, very end. So I'll blow it up again, scroll all the way over. We get the source of ground truth document class, as well as our prediction from the model. And we want these to match, right? Hopefully they match. We also have the probability here, or sort of like a confidence for determining how or what the model thinks about its own prediction. We can use all of this information in something called the binary classification inspector, and this is where we start to evaluate how our model performed. If you're familiar with classification metrics, I can go in and look at the confusion matrix here in the bottom. The area under the curve of the ROC curve itself here is about 0.9, so it's pretty good. It's not too good, it's not suspiciously good, but it's it's not 0.6 or something either. We have a good area under the curve. There's other stats we could look at here if we wanted to look at sensitivity, specificity, and then change the threshold and watch how those scoring metrics change as we get into the tails of the distribution, as well as the confusion matrix values. So overall, we can say, looking at this model does a pretty good job of predicting whether movie reviews are positive or negative. We could take this model that we've trained, write it out somewhere else, and send it new unseen data and do classifications on that unseen data. So I need to stop here with this part of the demo and hand it over to Lisa so we have enough time for other stuff later. But just wanted to give you the broad approach, how we look at this stuff with the nodes in KNIME, and then what an example might look like. But I will stop, and Lisa's going to talk to you about something more sophisticated, I think, topic modeling.
All right, thanks, Scott. I'm just going to share my screen. Please shout if you don't see my screen. So I will now continue with our next section, where we will be talking about something called LDA, which stands for Latent Dirichlet Allocation. And it is something you use for topic modeling, or you can do it as like topic modeling. But before talking about LDA, I will quickly recap some information about clustering. And later on, I will move on to the KNIME Analytics Platform and show you a topic modeling workflow. Now, just a quick recap, what is clustering? So clustering is a method to group together objects in your data set into so-called clusters or groups, so that the objects within the same cluster are as similar as possible, and objects with different clusters are as dissimilar as possible. Now, clustering is used in many approaches, and topic detection would be one of them. And against this background, we would say we find groups of similar documents. What you can see here on the right is a scatter plot that is trying to visualize your clusters in the data set. So what you have here is a ton of data points, and we clustered them into 8 clusters, and we added this sort of like color coding that we colored each cluster, or gave each cluster a certain color. And now what you can see here is relatively clearly that all the data points that have the same color are in a similar spot in the scatter plot. So just to give you a rough idea what clustering means. Now, clustering is an exploratory method, so it's an unsupervised learning technique. And the idea is that you don't know ahead of time what your clusters are or what the patterns in your data set are. And this is very much different to classification, because with classification, for example, you usually know the classes beforehand or the groups beforehand, and there you just take your data points and assign them to some classes. And with clustering, however, you don't really know that, and you just try to find patterns in your data set. Let's say 5 clusters, but if it didn't work out and it is not really the number of clusters you're looking for, then you might need to change this number. So it's very, very exploratory. There are a couple of notes in KNIME which you can use for clustering in general, so for all the different clustering methods out there. And this also includes the clustering of numerical document vectors. Now, just very quickly showing you or talking about how to visualize clusters. I'm not going into detail here, but as I just said, there are a couple of different clustering methods out there. For example, k-means or k-meta-reads clustering, with hierarchical clustering, density clustering, and so on. And basically for each of these clustering methods, there is a way how to visualize them in KNIME as well. One example would be also what I've just shown on the slide before. If you do, for example, k-means clustering, you can plot your data points into a 2-dimensional scatter plot. You can assign colors to your different clusters, and if your clustering was good, you would see visually really the different clusters or groups of data points. Similar holds true for a density-based clustering, what you could see up here. So you could also plot it in a scatter plot, for example. If you do hierarchical clustering, it's a bit different. You have the standogram usually that shows your clusters in the hierarchical-based clustering. There is a node for that in KNIME too. As I said, I'm not talking about in too much detail about it. One thing I want to mention is if we're talking about visualizing clusters, usually the data in real life is not two-dimensional. You often have more than just two columns or features that are important. So what you probably need to do if you want to visualize them or plot them is to reduce the dimensionality, and there are different methods or techniques you could use for that. For example, the TSNE algorithm would be one method to embed high dimensional data, but others exist. And also for those, we have nodes in the KNIME Analytics Platform. Now, let's talk about topic modeling. So with topic modeling, what do we mean by that? Under topic modeling, we understand to discover different topics within a set of documents, which we would call a corpus. And we're using an algorithm basically to find out what the topics might be that are hidden in our corpus. Now I say hidden, that's because the topics are actually hidden or latent, which means that we don't know ahead of time what the topics might be. And a topic is basically just a construct between words and documents. So the overall goal of topic modeling is basically to discover these hidden topics, and then it is up to you to interpret those topics so that you can eventually get a meaning out of your corpus. Now, in other words, what the algorithm is doing, or what the algorithm can do, is it can assign your documents to different topics. So you need to tell the algorithm how many topics you want to find, let's say 5. And then the algorithm goes ahead and assigns all of your documents to each of the 5 topics, but with a different probability. And some probabilities might be higher. For other topics, it might be lower. Now, what the algorithm cannot do is to tell you what the document actually talks about. So you can't expect, or that's not what's going to happen, is the algorithm won't tell you that document 1 talks about sport and document 2 talks about animals, for example. You only get basically the topic distributions, and then you get a list of words that is assigned to the documents, and then you need to have a look at the words, and then you can interpret what each topic talks about. There are multiple algorithms out there with which you can do topic modeling. As I said, I talk about latent Dirichlet allocation, or LDA. What these algorithms all have in common are there are 2 assumptions that apply to all of the algorithms, or to all of the approaches. First assumption would be that each document consists of a mix of topics. This means each document talks about multiple topics and not only about one topic. And the other assumption would be that each topic consists of a collection of words. So we would also call it a bag of words, and that just means that the order of the words doesn't matter. What is important to interpret the topic or to understand what the topic is about are the words itself. And yeah, their grammatical role or their order doesn't matter. All right, now let's talk about the LDA. One thing up front, I'm not going to talk about it in great detail. Also, having a look at the time, try to keep it short. I just want to give you a rough idea what the algorithm is doing or what you can expect, but I'm not going to talk about how it happens in detail. So here's what we know. The LDA is a generative statistical model. It is an unsupervised learning approach. And what it is trying to do, it's trying to find the topic distributions for each of your documents based on the words in the document. Now, what is or lies underneath the document are some document to topic allocations and topic to words allocations, some alpha and beta hyperparameters. But yeah, I am not going to dive deeper into that. But if you want to read up on it later after this webinar, So alpha would be the document to topic allocation, and beta would be the topic to word allocation. I want to show you this slide instead. This might make the things a bit clearer that I'm trying to explain to you. So what you have here on this slide, you see here at the top, you have your corpus. It's a bunch of documents. And you can also see that each document is basically talking about covering all of those topics, but this can be to a certain extent. So this means document 1 could talk mainly about topic 1 and topic 2, but for example, only very little about all the other topics. The topics are the things that we want to find out. These are the hidden variables. And what you have here at the bottom is a bunch of words. We get these words from our corpus. So those are words that appear in our documents. And each word is associated to one or multiple topics. So this could mean that, for example, word 1 is associated to topic 1 and, for example, to topic 5, but not to topic 2, 3, and 4, for example. Each word also would have a weight, and this weight would indicate how representative the word is for said topic. And what the algorithm is trying to do, it's trying to find out these weights here, these topics to document weights and words to topics weights. Now, what I show you here is this maybe might make it a bit more clear. So what you see here is an actual output, how it will look at KNIME Analytics Platform. So down here you have the node for it. It's a topic extractor node. This is the one you would be using, and you feed it in a bunch of documents or a series of documents. And then what you get out of it are 2 tables that are important for us right now. This first one, the document table of topics up here, and the topic terms table, which is here at the bottom. Now let's have a look at the first table real quick, this document table of topics. So it basically gives you for each document a series of probabilities, and those probabilities refer to the topics. So in this example, we told the algorithm to find 8 topics. That's why we have 8 probability columns here for each document. And it then assigns each document to the topic with the highest probability. So if you look at the first row, you see that the topic 3 has a probability for about 61%. So it mainly talks about this topic, and this is also why the algorithm assigned first document to topic 3. And like that, it assigns all the documents. So this is the first part. So table 1 shows you what is the main topic the document talks about. To find out what each topic means, you need to look at the second table here, the topic terms table. In here, you find all the words that are associated with all of the topics, and you also find their weights. And by just looking at this table, you can go ahead and interpret the topics. So for example, you see topic 0 has the words like firm and investment and performance and stuff. So we can interpret it and say, okay, topic 0 is about some investment strategies, for example. And just like that, you can interpret all of your topics. Now, what I want to show you next is a workflow in KNIME Analytics Platform. I hope you can still see my screen. Now I'm in KNIME. So what I want to show you is this workflow here, which applies the LDA algorithm to extract topics from a set of documents. But here, what the workflow is actually doing, so it reads in some data and is doing the topic modeling, but then it goes a step further and visualizes the clusters, and also allows you to filter basically or select those documents that refer to the topic that you're actually interested in. So it makes it easier to read in large amounts of data, because instead of like reading 1,500 medical abstracts, you might end up reading just 70, which is still a lot, but yeah, still it's less to read. So what is this workflow doing? So we start here in the beginning, we're reading in our data. We are dealing with around, with 1,500 medical abstracts, which we got from PubMed. So So PubMed is an open source, freely available data source. We have those medical abstracts here, and it's talking about certain diseases. We have for disease located with it, which is here in this PubMed query column. So just as a background, what data we're dealing with. We are also doing some pre-processing that I'm not going into detail here, but it's basically what Scott also already showed to us earlier. What we need to do in the topic extractor node, we need to tell the data source or where the data is coming from, which would be the pre-processed document column. And we need to define the number of topics and the number of words per topics. Here, usually, you can do a good guess. I decided to search for 8 topics and I want 20 words per topic, but you can, of course, try it out with different settings. Down here, you find additional parameters, but I just use the default values. And what I get out from this node would be this table here. So you have for each document this series of probabilities. It's very similar to what I've shown to you in the slides already. And you have this assigned topic column here. Additionally, of course, you also have the topic terms table. This is also very similar to what I've shown to you in the slides. We defined 20 words per topic and we have 8 topics. So we have 160 words in this table. And now from here, you can read the words that belong to each topic and then interpret your topics. Now, so far, this would be topic modeling in general, but why is it useful in real life? Why do we want to do this? What we are doing here at the other parts of the workflow is we are visualizing our clusters. So we just takes a little bit to load this dashboard. You can here see a 2-dimensional representation of our, 8-dimensional data set in this case, because we have 8 topics. And now what you can do here, I mean, it clearly shows you already the clusters and everything. It's similar to what I've also shown in the slide before. But what the cool thing here is now that you can actually select topics you are interested in. So for example, if you select topic 7, then all the data points that are, or all the documents that belong to this topic 7 are, first of all, highlighted here in the plot. And if you scroll down, you can actually see a table with all the selected documents, all the documents that belong to topic 7. And what you can get from this view here is, well, first of all, most documents that talk about the alcohol dependence disease are in one topic, which makes sense. But you can also see that, for example, this 3rd document is also assigned to topic 7, but it is talking about a different disease. What you have, or what you can get from that is you see, okay, maybe this document is interesting for me too. I'm interested in documents that talk about alcohol dependence. Maybe this abstract then, or this article is interesting too. And now you also see here on the right, by the way, all the words again that are assigned to topic 7, so you get a better understanding what the topic talks about. And last thing this workflow is doing, it visualizes or shows you here a word cloud. So the words you see here in this cloud are all the words that are associated with topic 7, because that's what we selected in the step before. Whoop. Gone, here it is. And now what you can do, in here you can now see which keywords are most important, hence the bigger ones are more important, and the smaller words, they have a lower weight, so they are maybe not as important. And here you can select now certain keywords that are especially interesting to you. So let's say you are interested in keyword research, and now if you scroll down, you get all the abstracts that belong to topic 7, plus contain the keyword research. And if you scroll down all the way, you can now see you have here 74 entries filtered from the 1,200 something documents that belong to topic 7. So by that, you can just read a smaller amount and save some time. Now, speaking about time, let's check the clock. I would just, leave it like here. This would actually be just an idea or a real life example behind topic modeling. And right, I would hand back over to Scott so he can show us the last demo of the day. Yeah. And
Okay, yeah, let me do that right quick.
Here.
Share my screen. So this is the last thing, and I'll just take maybe 3 minutes to show you this so we can have enough time for outro and questions. I showed you a screenshot of this earlier, what this dashboard would look like, and I guess we can start with the dashboard. While Lisa was talking, I just ran this analysis again to get some live tweets. What this dashboard shows is what are people currently tweeting at the main Twitter account. And so you get a few things here. We have a bar chart that we've displayed up here that classifies tweets as negative, neutral, or positive. We get a word cloud over here that shows, the actual words that people are mostly tweeting about. And then if you scroll down, you also get the actual tweets themselves. They're paginated here, so it just shows you 10, but I think I did 50 here, so we could, show more. And there's interactivity in this dashboard too, because if I wanted to say, well, who's talking about their passwords, for example, or their accounts, I can actually click on words over here in the word cloud, and those tweets that contain that will be highlighted, like there's a neutral tweet that is actually talking about accounts or passwords. I could scroll down and see those, or I could even filter those to have only those appear. So it allows me, this dashboard allows me a way to kind of play around with the data, especially if I'm, maybe a business analyst and not a data scientist who knows how to do this analysis. I can still work with the data. Perhaps unsurprisingly, you see that this being social media, almost everything is negative or neutral, and people have very few positive things to say. People like to gripe on social media. That's just kind of the nature of the medium. How do we build this workflow? Well, this is it. We have over here this tweet extraction component, and if I go inside it, you can see that I have, a few parameters. Whoops, made it go away. To set my, login for Twitter. We have a connector to Twitter, and then we have a Twitter search node, and this is where we actually say, what account are we going to check on? How many tweets should we pull? We bring all that information back in, start analyzing the tweets. We actually filter out emojis because those are common on Twitter and they cause problems for the visualization, so we get rid of some of those. Our handy strings to document node, which, as I mentioned, is super important. You'll see these over and over again at the beginning of your analyses. We've already trained a model in this case. So we do the enrichment and pre-processing, kind of like we did before, right? Similar steps, case conversion, stemming, stop word filtering, and so on. That's in this component here. And then ultimately, we have two different models that we read in. The first one is actually the vector space of it's essentially the form of the matrix that the model originally was trained on, right? So that's going to contain all of those different words, all those different terms in the column that the model was trained on. We use the document vector applier to make sure that in our new unseen tweets that we're bringing in, we use the same vector space so that we're comparing apples to apples. Once we apply them to that vector space, then we actually use the model that was trained before. In this case, it was a random forest model. We bring that model in, use the random forest predictor to actually get the predictions of positive, neutral, negative on these unseen tweets. Then we take that information, and that's what's used to generate the visualization. In the visualization component, there's a little bit of pre-processing with these yellow nodes that you see, but you can also see, hey, there's our bar chart. There's our table view. There's our tag cloud. We can take all of those visualizations and rearrange them however we want. That's what ends up forming this dashboard in the end. So it's we call this a data app in KNIME. This is completely customizable so that you can, see what you need to see, focus in on the things that are important for the task that you're doing. So this workflow, as well as the others that we have showed you today, the three, are all available on the KNIME Community Hub. And maybe I'll pass back to Lisa. So Lisa, you can show people, how can they get a hold of this stuff if they want to try it out for themselves?
Right. So, so this was pretty much all that we wanted to show to you today. Now, before going on to the Q&A, let me just get another 1 or 2 minutes to just wrap up the session and give you some information. So first of all, this text processing in KNIME, like if you've never done it before, then you need to be aware that it is part of its own extension. So you need to install the KNIME text processing extension to get access to all of the nodes that we have shown to you. You can do this either via from the KNIME Analytics platform to go to File and install the KNIME extensions, or the more modern way would be to go to the KNIME Community Hub and search for the KNIME text processing extension there, and then you can just drag and drop it into your workflow. Now, speaking about the KNIME Community Hub, you can find tons of other use cases and examples, not only about text processing, but also about text processing on there. Like, find workflows for PDF parsing or some deep learning approaches for NLP and all kind of workflows, and also the ones that we have shown to you today, you will find on the KNIME Community Hub. If you are working on any other text processing related use cases, let us know in the chat. It's always interesting to us to know what you are working on. Then another thing, if that was interesting to you, but not enough information, I could recommend you, or I want to recommend you the From Words to Wisdom book. It's available on the KNIME Press webpage. So if you go to knime.com/KNIME-Press, you can download it there with the code intro-tp-0426. You get the book for free, actually, for a limited time. So yeah, if you want to do a deep dive on text processing, I can recommend that to you. And the very last thing for the Q&A, in case you want to stay connected with us, or in case you still have questions after this webinar and would like to reach out to us, yeah, feel free to contact us on any channel or reach out to Scott and me as well on LinkedIn. And with that being said, I would say we do the Q&A now. Are there any questions in the chat?
I'm not seeing any questions, but Scott, I want to know if I know you answered, you typed out some answers to some questions. I want to know if, are there any that you want to?
Sure, we can maybe address a few in the remaining minutes we have. Someone had asked if this is from Shiva. I've developed some problem-specific tools in Python and I want to use them. Is it possible to add my modules in KNIME? And the answer to that is yes. I mean, KNIME is a low-code, no-code tool. That's kind of our aim, right? But if you want to use Python, we have nodes that support that. There's actually several different Python nodes. For that purpose, probably the Python script node would be the most useful. You can also actually, in the latest release of KNIME, which is 4.7, you can actually write your own custom nodes using Python, right? So you can make your own little colored blocks on the screen and drag it and drop it and share it with your other folks on your team and do it that way. So there's different approaches, right? You can combine Python within KNIME. You can make new nodes with KNIME. You can also reach out and call Python, like a Jupyter notebook, right? If I have a Jupyter notebook, I can call that from within KNIME. I can also call KNIME workflows from within a Jupyter notebook, and you can actually see the workflow, an image of it within your Jupyter notebook, and see that it's run and everything. So there's a lot of back and forth there. It's not just Python too. We also have support for other languages like R if you're more of a statistician, Java. If you want to use code, you can, but we try to give you an opportunity or a platform that supports not using code. Maybe one other question here. I think you answered this one, Lisa, and it's a term that I just used and without defining it. Someone asked what a token was. You want to grab that one?
Oh, right. Yeah. So, I mean, basically, when you have like large text input, what you need to do is you need to break it down into smaller pieces. We have seen different reasons for that. Could be the pre-processing, could just be that it's better usable from whatever algorithm you're using. So whenever you break down some text input in smaller chunks or smaller pieces, you would refer to them as tokens. As I said in this example, if you have a sentence and you break it down in words, then the words are the tokens, but it can be smaller. It can be characters. It can be subwords. Often you do tokenization before you do a stemming or so. So yes, I hope this answered the question.
Thank you everyone for joining today. Big thank you to Scott and Elizabeth and the team at KNIME. We really appreciate having you all. So thank you, Scott. Thank you, Elizabeth. Hope everybody has a good rest of their day.
Thanks for hosting us.
Thanks everyone.